Hello dear students, all of you welcome to Vidyanand classes. Today we will discuss the sixth properties of inverse trigonometric function and its application. P6, that means property 6. Case 1, for x greater than equal to 0, less than equal to 1. Sin inverse x is equal to cos inverse root of 1 minus s square, which is same as tan inverse x divided by square root of 1 minus s square, x not equal to 1, which is same as cot inverse root of 1 minus s square by x, x not equal to 0. Sec inverse one divided by root of 1 minus s square, which is same as x not equal to 1, which is same as cosec inverse 1 by x, x not equal to 0. Sin inverse x is equal to cos inverse root of 1 minus s square, which is same as tan inverse x divided by root of 1 minus s square, where x not equal to 1. Cot inverse root of 1 minus s square divided by x, x not equal to 0. Sec inverse 1 divided by root of 1 minus s square, x not equal to 1. And cosec inverse 1 by x, x not equal to 0. All are equal. Let us prove sin inverse x is equal to cot inverse root of 1 minus s square divided by x, x not equal to 0. This is same as this is same as this is same as this. Sin inverse x is same as this, and sin inverse x is equal to cosec inverse 1 by x. Let us prove sin inverse x is equal to cot inverse root of 1 minus s square divided by x, where x not equal to 0. Let y is equal to sin inverse x, which implies and implied by x is equal to sin y. Since sin, so that close bracket minus pi by 2 plus pi by 2 close bracket 2 close bracket minus 1 close bracket. The function, that is sin, defined from this set to this set is invertible. That means bijective. Its inverse is exist, which implied and implied by sin inverse, so that close bracket minus 1 close bracket 2 close bracket minus pi by 2 plus pi by 2 close bracket. The sine function is invertible when it is defined from this set to this set. So we can write y is equal to sin inverse x, that implies and implied by sin y is equal to x, which implies it by cos y is equal to root of 1 minus sin square y, which is same as root of 1 minus s square, which implies it by cot y is equal to cos y divided by sin y. Cos y is equal to root of 1 minus s square, sin y is equal to x. It is taken as equation 1. The sine function is inverted from this set to this set. So we can write y is equal to sin inverse x, x equal to sin y. Cos y is equal to root of 1 minus sin square y, that implies 1 root of 1 minus s square, and cot y is equal to this. We have to show the cot function is invertible or not. Y is equal to sin x, sin inverse x. That implies y subset of open bracket 0 pi by 2 close bracket. Since x not equal to 0, x greater than 0, as x greater than 0, less than or equal to 1. Sin inverse 0 is 0, sin inverse 1 is pi by 2. So the left hand side is opened and the right hand side is closed. That implies y subset of open bracket 0 pi by 2 close bracket, that subset of 0 open bracket 0 open bracket pi, which is equal to this set represent the range of cot inverse. It is the range of a cot inverse. Y subset of this set, which is the subset of this set, that is open bracket 0 pi open bracket, which is same as range of a cot inverse. The cot function is invertible in this set. The range of a cot inverse is open bracket 0 pi open bracket, in which y is exist. Y is invertible and y belongs to this set. Y belongs to this set and this subset of this, which is same as range of a cot inverse. That means cot is invertible in which y is exist. Implies cot is invertible. That means the cot function is bijective or invertible when it is defined in this set. Its range is this set in which y is exist, so that y is invertible. If a function is invertible in an interval, then the function which is invertible in an interval, it must be invertible in the sub interval. If a function is invertible in an interval, it must be invertible in its sub-interval. This is subset of this. So, cut function is invertible and the cut function is defined by cut y is given by this, which is invertible. Equation 1 implies cut y is equal to root of this, or y is equal to cut inverse root of 1 minus s square divided by x. X greater than 0, less than or equal to 1. Since x not equal to 0. That means cut is invertible. Y belongs to this set. This is subset to this set, which is the same as the range of a cut inverse. So, cut function is invertible. Y exists in this set, which is invertible. That means cut y is invertible. So, we can write cut y is equal to this set, cut y is equal to this, or y is equal to cut inverse. What is the value of y? Sin inverse x is equal to cot inverse root of 1 minus s square divided by x. X greater than 0, less than or equal to 1. Hence it is proved. Hence the statement is proved. Sin inverse x is equal to cot inverse root of 1 minus s square divided by x. Clear? Clear? Okay. Example. Sin inverse 1 by root 2, which is same as sin inverse x is equal to cos inverse root of 1 minus s square. Cos inverse root of 1 minus s square 1 by 2. Since sin inverse x is equal to cos inverse root of 1 minus s square, which is same as cos inverse 1 divided by root 2. Sin inverse x is equal to cos inverse root of 1 by root of 1 minus s square, which is same as tan inverse x divided by root of 1 minus s square. This by this, which is equal to 1. This by this, that is equal to 1. Which is same as tan inverse x. Tan inverse x divided root of 1 minus s square is equal to cot inverse root of 1 minus s square divided by x. So, cot inverse 1, which is same as sec inverse sin inverse x is equal to cos inverse root of sin inverse x is equal to cos inverse root of 1 minus s square, and sec inverse is equal to 1 divided by root of 1 minus s square. Cos inverse is this value, sec inverse is this value. Cos inverse is equal to 1 by root 2, so it is the sec inverse root 2, which is same as cosec inverse sin inverse x is equal to cosec inverse 1 by x when x not equal to 0. Sin inverse x is equal to cosec inverse 1 by x, that means root 2, which is same as pi by 4. That means sin inverse 1 by root 2 is equal to pi by 4. Cos inverse 1 by root 2 is equal to pi by 4. Tan inverse 1 is equal to pi by 4. Cot inverse 1 is equal to pi by 4. Sec inverse root 2 is equal to pi by 4. Cosec inverse root 2 is equal to pi by 4. Clear? Clear? Okay. Note down. Next, property 6. Case 2. Property 6, case 2. For x greater than or equal to minus 1 less than 0, prove that sin inverse x is equal to negative of cos inverse root of 1 minus s square, which is same as tan inverse x divided by root of 1 minus s square. X greater than equal to minus 1 less than 0. So x not equal to minus 1, which is same as minus pi plus cot inverse root of 1 minus s square divided by x. X less than 0. X not equal to 0, which is same as minus sec inverse 1 divided by root of 1 minus s square. Cos inverse root of 1 minus s square will be sec inverse 1 divided by root of 1 minus s square, which is same as, here x not equal to minus 1. If x is equal to minus 1, 1 by root of 1 minus s square does not exist. Cosec inverse 1 by x. X not equal to 0 since x less than 0. Sin inverse x is equal to minus cos inverse root of 1 minus s square, which is same as the tan inverse x divided by root of 1 minus s square, which is same as minus pi plus cot inverse root of 1 minus s square divided by x, which is same as minus sec inverse 1 divided by root of 1 minus s square, x not equal to 1, and cosec inverse 1 by x. Proof. Let us prove sin inverse x. We can prove sin inverse is equal to this or this or this or this or this. Let us prove sin inverse x is equal to minus of pi plus cot inverse root of 1 minus s square divided by x. X greater than equal to minus 1 less than 0. Let y is equal to sin inverse x and x is equal to minus alpha. Alpha greater than 0. Y is equal to sin inverse x and x equal to Put x is equal to minus alpha, where alpha greater than 0, which implies this x greater than equal to minus 1 less than 0. X is taken as minus alpha greater than equal to minus 1 less than 0. Multiplying minus 1 everywhere, alpha will be multiplying minus 1 everywhere, it gives alpha greater than 0 less than or equal to 1. Clear? Alpha greater than 0 less than equal to 1. So y is equal to sin inverse x is taken as minus alpha, which is same as minus sin inverse alpha. Since sin inverse minus x is equal to minus sin inverse x. Condition x mod less than or equal to 1. That means x greater than equal to minus 1 less than equal to plus 1. Since alpha greater than 0 and less than or equal to 1, it is true. That is x greater than equal to minus 1 less than equal to plus 1. This is subset to this. So it is true. Y is equal to minus sin inverse alpha, is equal to minus cot inverse root of 1 minus alpha square divided by alpha. Since in property 6 case 1 we have proved sin inverse x is equal to cot inverse root of 1 minus s square divided by x. Condition x greater than equal to 0 less than here, since x is at the denominator, x greater than 0 less than equal to 1. In property 6 case 1 we have proved sin inverse equal to this. Here alpha is alpha greater than 0 less than equal to 1 implies this sin inverse alpha is equal to minus cot inverse root of 1 minus alpha square divided by alpha. Clear? In property 6 case number 1 we have proved sin inverse x is equal to cot inverse root of 1 minus s square divided by x when x greater than 0 less than or equal to 1. Here alpha greater than 0 less than or equal to 1, we can write sin inverse alpha is equal to cot inverse cot inverse root of 1 minus alpha square divided by alpha. Which is same as, so this equal to this, which is same as cot inverse minus of root of 1 minus alpha square divided by minus alpha. Minus minus cancel. Which is same as minus cot inverse, which is same as pi minus cot inverse root of 1 minus alpha square divided by minus alpha. Since cot inverse x minus x is equal to pi minus cot inverse x for all x belongs to set of real numbers. In property 5, we have proved cot inverse minus x is equal to pi minus cot inverse x for all x belongs to set of real numbers. It is taken as minus, it is taken as x. It is taken as x minus root of 1 minus alpha square divided by minus alpha. It is taken as x. So cot inverse minus x is equal to pi minus cot inverse x, which is same as minus of pi plus cot inverse root of 1 minus alpha square divided by minus alpha, which is same as minus pi plus cot inverse root of 1 minus s square divided by x. Since x is taken as minus alpha, s square is equal to alpha square, minus alpha is equal to x is equal to minus alpha, s square is equal to alpha square. Therefore, y is equal to sin inverse y is equal to minus of pi. Therefore, y is equal to, y is taken as sin inverse x, which is same as minus pi plus cot inverse root of 1 minus s square divided by x. Sin inverse x is equal to minus pi plus cot inverse root of 1 minus s square divided by x. Similarly, we can prove sin inverse x is equal to minus cos inverse root of 1 minus s square, which is same as tan inverse x divided by root of 1 minus s square, and so on. The other results similarly can be proved. Hence proved. Sin inverse x is equal to this. Hence proved. Clear? Example. Sin inverse minus half, which is same as minus pi by 6. Since sin 30 degree is equal to sin inverse minus half is equal to minus sin inverse half, which is same as minus pi by 6. Since sin 30 degree is equal to half, every inverse trigonometric function represent a radian angle. which is same as sin inverse x minus half belongs to this set. When x belongs to this, get x greater than equal to minus 1 less than 0, these are possible. Sin inverse x is equal to negative of cos inverse root of 1 minus s square, that means 1 by 4, which is same as cos inverse, which is same as cos inverse root 3 by 2, which is same as negative side, minus of cos inverse root 3 by 2, which is equal to tan inverse sin inverse x is equal to tan inverse x divided by root of 1 minus s square. This by this minus 1 by root 3, which is same as minus pi plus cot inverse minus root 3, which is same as minus pi plus 5 pi by 6. In the previous class, we have proved cot inverse minus root 3 lies in second quadrant. Cot inverse minus root 3 is equal to 5 pi by 6. Tan inverse x divided by root of 1 minus s square is equal to pi minus pi plus cot inverse root of 1 minus s square divided by x, which is same as minus pi by 6, which is same as minus sec inverse 2 by root 3. Since this is same as this, which is same as cosec inverse sin inverse x is equal to cosec inverse 1 by x, that means sin minus 2. All are equal. Sin inverse minus half is equal to minus pi by 6, which is same as cos inverse minus cos inverse root of 1 minus s square, that means root of 1 minus 1 by 4, which is same as minus cos inverse root 3 by 2. Sin inverse x is equal to tan inverse x divided root of 1 minus s square. Sin inverse and cos inverse gives tan inverse this by this, that is equal to minus 1 by root 3. 2 cancel, which is same as tan inverse x is equal to this result. So we will write minus pi plus cot inverse minus root 3. But it lies in the second quadrant, whose value is 5 pi by 6. And this sum is minus pi by 6. Minus cos inverse root 3 by 2 is equal to minus of sec inverse 2 by root 3. Cosec inverse minus half is equal to cosec inverse minus 2. Clear? All are same. Next example. If sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2, then find the value of x. Find the value of x. Answer: if sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2, Then find the value of x. Sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2, which implies sin inverse x by 5 plus sin inverse 4 by 5 is equal to pi by 2. Since sin inverse 1 by x is equal to cosec inverse x, condition x mod greater than or equal to 1. Here x is equal to 5 by 4, which is same as mod of 5 by 4 greater than 1. Here x is equal to 5 by 4. So sin inverse 4 by 5 is equal to cosec inverse 5 by 4, which implies sin inverse x by 5 plus cos inverse root over of 1 minus 16 by 25 is equal to pi by 2. Sin inverse x by 5 plus cos inverse root of 1 minus 16 by 25. Since sin inverse x is equal to cos inverse root of 1 minus s square. Condition x greater than equal to 0, less than equal to 1. Since x is equal to 4 by 5 belongs to this set, we can write this equal to this, which implies sin inverse x by 5 plus cos inverse 3 by 5 is equal to pi by 2, which implies x by 5 is equal to 3 by 5. Since sin inverse x plus cos inverse x is equal to pi by 2, x mod less than or equal to 1, and this x is the same as this. Sin inverse x plus cos inverse x is equal to pi by 2, condition mod of x less than equal to 1, and this x are same. Sin inverse x by 5 plus cos inverse 3 by 5 is equal to pi by 2. So this is the same as this. X by 5 is equal to 3 by 5. Implies x is equal to 3. Is the correct answer. Is the answer. Clear? Clear? Okay. Second method. Sin inverse x. Sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2. Sin inverse x by 5 is a radian angle. Cosec inverse 5 by 4 is a radian angle. Sin inverse x by 5 cosec inverse 5 by 4 are two angles of a of a right angled triangle whose sides are x, 4 and 5. Since sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2, this and this represent two angles of a right angle triangle. Since its sum is pi by 2. X, 4, 5 and x are the sides in a right angle triangle. It is 5 is the hypotenuse, 4 it is x. X is equal to 5 square minus 4 square root, that is equal to 3. Clear? Sin inverse x by 5 plus cosec inverse 5 by 4 is equal to pi by 2. This represent this and this are two angles of a right angle triangle, since the sum is pi by 2. X, 4, 5 are the sides of the right angle triangle. 5 is the hypotenuse, 4 it is the x. So x is equal to 5 square minus 4 square, that is equal to 3. Clear? Clear? Okay. Note down.